on-site, and we have our colleagues from CLS, experts for the CopPhil and cover monitoring service are here to hold this session with us today. And yeah, it's morning, and thank you for being here. So yeah, we can start now the training session for today. Okay, so again, welcome, and just a few housekeeping rules. So everything is recorded, and the materials you can find them later on the digital campus. So we're right now on the part 3 session. So thanks for being with us from part 1 up to now. And if you have questions, please feel free. We're happy to answer your questions right here. And yeah, just enjoy the session. And as a welcoming remark for CopPhil, have to play this video from the European Union ambassador. Okay, so those are again the CopPhil introduction words from the European Union Ambassador to the Philippines and endorsing the CopPhil project. So, as you have already attended the previous trainings, we've already learned about the CopPhil project. So it's an initiative that's wherein we wanted to make this Copernicus mirror site in the Philippines as a gateway here in Asia. And why are we doing this set of trainings? It's to have this local capacity for Earth observation. So we have learned about the project, which tries to link and also develop the pilot services. So we have three main pilot services. So ground motion, the second one, land cover, forest, and crop, and the third one, benthic habitat monitoring. And from part one, we had the fundamental courses. And then part two, we had the practical hands-on sessions and power on their applications. So we've had all these trainings from last year to this August. So we're now wrapping up the last two trainings. So maybe you have attended a lot of them. So thank you very much. So today we're having the application course for land cover. And as Monica's pointed earlier, we will have the final event where we can recognize all your efforts tomorrow. So please register with our registration form to ensure your spot for tomorrow. And you have to be there and yeah, enjoy. And then again, materials will be uploaded on the training platform, the digital campus. And then all by now you should have your accounts and you should have been enrolled into courses. And again, as a reminder, you can generate your certificates automatically by filling out the assessment forms and a small quiz. So yeah, we encourage you to really fill this out and like a course is marked completed when you actually generate your certificate. So please do some assessment there. So it's just very short. And yeah, so we can start beginning the session for land cover monitoring application. So we have here Etienne and Marion to uh, introduce us for the application course. With part two, we already had the hands-on session. We already learned about the land cover processing chain and also like the tutorial from learning about the satellite imagery to how we can do supervised classification with this set of satellite images to form different maps and also the related application. Now we can start to look at them and to how we can apply them into use cases. So I have here Adriana, so welcome.
Um, so I'm kind of allergic to microphone, so probably I will just talk out loud. Everyone is me right, or do I need the microphone? It's okay? Okay. Yeah. So thank you, Carla, for the introduction. Just switching of presentation. So maybe just a quick word of introduction. So my name is Etienne Lucas. I'm a PhD working at for CopPhil program with from CLS Group, which is the French company. And yeah, I'm glad to be here to talk to you about land cover application. So the idea here, I'm quite of an end user. I'm quite of a producer, data producer, not an end user. So the idea here is more to introduce you what is the land cover products from the CopPhil program, and then give you probably some ideas. But if you have some specific case on how to use it, I think it will be the way of presenting ideas and maybe starting from here or building your concepts and your work based on this data. So how everything will be done today. So I will present some generalities about land cover maps and presenting the CopPhil product. On the second part, I will talk about what is spatial geospatial analysis and the different sources that you can find in order to do your geospatial analysis. Third, we will go between the two, and the third part we will go on a little break. On the third part, we'll talk about ORIX exposure, and the idea is to do an exercise. So you probably received an email. You will receive an email. I corrected. About with a link to some data to download, and I hope everyone has QGIS at this laptop and QGIS installed. If you don't, it's please look at your neighbor. You can do it together. And on the last part, we'll go through some other cases, use cases, example found in literature. So I hope everyone's ready, and then we can do it. So land cover map. So land cover is the observed biophysical cover on Earth's surfaces, but at the difference of land use, it's not all the people use it. It's only described what's what is on Earth. So if you have built up, for example, don't know for sure if it's residential, if it's economic. Of course, if you go again on residential, you can cruise about this, but this last step of information is really often added by other sources of that. So here you have two examples of land cover. So the ESA world cover from 2021 and the actual Namibia footprints and cover. So which are both the first global data set of land cover and the last one, which is the local data set made for Namibia every 5 years. When you do land cover, you use a particular classification system with some different bases. So, meaning I'm not going into much more detail, but the idea is to separate using geophysical variables each task and going into details more and more going on the depth that is the classification. So here is an example which might be used the land cover classification system, which is a standard by the food and the FNU. So that's aware that it can exist all kind of system, non-classification system that exists. I know, for example, that in Europe, we use the Eagle classification system, which is very similar to this one, but also different. So be aware that there is classification classes that can depend on the land cover you're looking at. So talking about our product, so we're not going into detail because we have lots of courses talking about this. We have also practical courses talking about this. So please be welcome to look at this if you haven't if you didn't participate earlier. Everything is online on the web. But for the land cover, the CopPhil it came from a supervised classification based on it's using Earth observation data from two satellites, 17 and 2021. And the idea is to study the time evolution of one place. And for this, they determine which kind of land cover is it for the crops. And it's important to have large variation in time. If it's forest, then you have large area of vegetation and quite stable time. Also, it's supervised classification, meaning that we need a down data set, reference samples to be entered in the system, and as an output, we have our land cover maps. So a little bit more precisely. So here are the different data sets that are used in for the system. So it's approximation data, the sets, Sentinel-2, which is analytical sensor, Sentinel-1, which is SAR, and also for the DS count classification. So the idea of the counts for the 2020 baseline, which is year of processing for the network. And then the description of the main that you add the output of the chain. Also, we have we can components. We have the land rover here. We have the number of images of the new classification. So we have around 50 to 60 examples inside. We see that there is other area as well. So we can use kind of the carbon use for the physical connections. Here also it's of this learning. And more importantly, what you want to know is which level has to be done. So stable classification system has been given class. And there is other specifications which are minimal non-units. Using 1 year and those was minimal units for us to. Yeah, exactly. It's what it's saying. I mean, for example, you know, you of course, the forest will that's is also filters map to avoid false prediction and but you see that for classic, for example, for inland water or for land or there is no stream that we are producing about at 10-meter resolution. So it means that the smaller water body can find them 10 meters by 10 meters outside. So, so another example, so it will be after we will be working on the result. So maybe it's after or and with the computer matrix associated. Another product which is not yet available, but I introduced you that will change. Because network is interesting. As you see in this case, the most interesting is to compare the in time to changes to track urban sprawl or deforestation or some patterns inside the chunky things. So the decoration product, which will also be available for the complete platform, is kind of the type of same product. It's a big pasta roll. And the idea is quite the same as the product, meaning that you look at the combination at one place and you know the operations. And if you see a change in what the next topic, there's a big change now. So we change the classes, and then now we have no class. It's interesting in one thing that, on the contrary of the previous product, we need a lot of preference data each year or each time we want to actualize the map. Here, the idea is you just only need the length of the baseline length of that, and then each year see all the detection coming and if there is new changes. And so in the end, we have a change detection lab with the classifier change. And it's also based on radar and optical satellites or something like that. So here is first example some places where for 2024, where we can see between 2020 and 2024, the changes here. So here is the deposit area, and here it's space. It's solar panels and district. It's just it's I don't know exactly the name of the region of the administrative area. Okay. So let's talk now a little bit about geospatial data and what is geospatial analysis, basically. So geospatial analysis is a tool to understand the pattern and the relationships of space. So the idea is to study and analyze space components. So the idea is, for example, to see clusters of spots, spatial correlations, change over time. So to see what changing, like I said earlier, in the neighborhoods I was born or image after so special functions we can see what actually about what's actually what it's close to and cluster and stuff, which is less obvious in case here. We'll find a way to so as I said, it's really interesting to support machine learning for a lot of and for policymakers. So for urban planning, disaster risk prediction, resource management is really interesting. And so the idea is to have a cross combination of different sources, which are environmental data, structural data, infrastructure, other ways. So the idea is to combine all these sources, all these data, in order to have more information into topics. So, as I said, we need a multiple sources. So, here I don't do this because quite huge, famous and so maybe it's some place where when you can have some calorie to check. So later. So the access of data secret on the institute. We start with Google is but the thing that the institute there can be complex. You need to be assisting. There's some data groups could be these are more generalist so there are some students more issues natural concepts. But I work on that. So there are some last so as you can go of websites and then there are some times that can set on statistics on the markets so we have also project and also another like also solution for some other sources that you can find internationally. So you can find which are different data sources like sometimes some data. We have an example of the program before. So if you want to do that, so that are reduction to which is the biggest image for put from sensor to sensor. We can go to for example, from this last out of planets, and see all of these images. So it's really nice to use brief so it's also going to observe. You also manage such services in balance as well. So more special data. Yeah, there is also some other source assets like for like open super, Snapchat, open your there are projects that have photos and even also some institutional assets coming from the FNU and the World Bank, for example. So a lot of data sources, but when we talk about data, it's what is data? So if you want to have a or you can talk me and says well, we are really in the short we are not very large crowd right now. So I mean we can have a open discussion. This don't explain to so we saw where to gather some data, but how we can what are the kind of data we can buy. So probably you know this, but there are two main kind of data, which is register data. So it's representation of as an image. So it's a grid of cells divided regularly. So it's mainly used to share, for example, identification assets or the is also in this format. This kind of data, so there are different formats like GOT, PNG, shape, basically every image is also. And the other kind of data is vector data, where you want an object with its geometric attributes, geometry, and also some other attributes as well. So you can represent it points, for example, lines, polygons, so you can shapes. To have an example. And the main format you can find is for it's very well known shape file, but I think that geopackaging is really not represented as the truth because it's really interesting file. First, because it's only one file instead of shape file, which are 5 files each time, which is a nightmare when you share data. And every time most everyone lost one file and so can be also confusing. So there are a lot of different formats you can encounter. So also when you have this data, the question is more how you can access it. So you can have some web portals or platform, like for example the CPSC, the Copernicus browser, is a platform where you can manually download each image, which can be a format. The webmap services, which is technically not a place where you can download format, but only run a program, but only to visualize it. But there is also another thing which is APIs, which is a way to download a large amount of data. So the idea is to code a little bit, but the idea is also to have to avoid user interface, partial user interface, in order to have a more easier access and quick access to the data. So there are a lot of APIs as well. The one I use for my work is mainly the Copernicus space ecosystem API, which allows me to access immediately to the Copernicus catalog. So all data sets. Yeah. And one last thing, it's how we can. It's the other things you need to consider when you use geospatial data. So first, the metadata, it's the information described in the product you are using. So especially the license, you need to know if you have the right to use the data set, for example. But also the data processing, the data source, and so on. Also, there is the geospatial data could be quite heavy, so you need to take care of storage and how to store the data. And how you will compute it and process also. If you see over consideration, I will gladly take any more information as well. So that's it on the geospatial data analysis. The question is about how to use geospatial analysis approach. pointer. I know you because I just a quick run which is right. And the disasters there's management and we still about to the blood mounts. Once we sound up from it's about to actually because just isn't available that's fine and it also do that. So these are people so we also use just for showing data or are you on the processing side like side of it like focusing data? For example, use okay. To get content data with that information for use. Yes, I agree. Yeah, it's been a project. Um, okay. So we oh sorry, I just I have a sorry. Uh, okay, so let's talk a little bit on this presentation of use case. Then we do a short break and then start the exercise. So the idea here is about risk exposure to natural hazards. So the idea of risk is the intersection of hazard, which is a disaster. For example, so yeah, hazards, hazards from the support, but there are also overhanging hazards such as slides, seismic hazard, and so on. So the idea is the intersections of hazard, such as like the exposure, meaning like we have a city just below slope, which is ambient, very is there any exposition potential? And the last part is vulnerability, meaning that if you have some system, for example, for flood like dams, or if you adapt the houses, you have more or less vulnerability to some hazards. So it's a good example of change function risk analysis because we are intersecting the hazard with over layers of information to define, for example, the exposure. So hazard and population. You can filtering data by location, type or slope. So you can use several information to determine if this population are under high level risk or low risk, and of course quantifying and having sites on affected areas and people. And it's a really important tool for decision makers because a well-suited adaptation and mitigation measures are really often depending on the good knowledge of the risk. If you don't know exactly where the fruits are, it's difficult to build a good dam or to relocate people. And now it's okay. So I will show you some example. So in CLS group, we are working inside called the company service, which those energy study for the spatial analysis or nearly needs perhaps to interventions on offenses. So maybe there is other testing which is always allowed to offenses. So there is a specification of those on the board, and then it sticks to produce a lot of scenarios. Here for the invitation 2022 so yeah, it's since and good customers on some results. So it's a classical where program maps could be interesting. So here it's directly responding after a disaster, but you can also do some assessment beforehand, meaning that you first try to identify high risk areas in order to have a lawsuit planification and yes, also service developed by several and which is a service, of course, also risk. So the idea is to model some concept plans with different scenario of change. So basically, here is for one scenario for 2009, and see where is the house. So it was level of food, and then there is some indicators which are basically putting us out in the center with leftovers and over type of plots in order to see to assess the different for example, when you are in a residential area, this large nearest best areas that you are events or pastor or area, you can have more as well. So that's an example as well. So the idea here is to try to work a little bit on floods and landslide hazards in that sense. So the idea here is we will work a little bit with a flood hazard map and landslide hazard map that has been created by the National Ocean Assessment of Hazards project, and with some owl uncovered data and the administrative entity check file from memory. What you could do, we will open QGIS. Can I just put my computer here for This way I can just look at the screen at the same time. And, if you don't mind. Okay. Yes. So I will go with you for the whole steps. What first things you can do? I want to open QDS, maybe that takes some time. Okay. Okay, Mike. So the software. So we will use several plugins. So do you know how to install custom plugins in QGIS? Yeah. So there is plugins we need to install. The first one, which is quite mandatory, is the that plugin. So actually, there is one. There is one option. So there's sorry, I'm still. Okay. 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 So here you should have plugins and manage and install plugins. And here we'll check on. Okay. You need to have to look at the I don't have my. I'm sorry, group stat plugin. Sorry. So this one, you're looking in search to group stat plugin. And this over plugin is also interesting in order to have base map. So if you could install the data search catalog file and the group stats plugin, then we will do install. Data search catalog client. Yeah, it's a bookmark service. Sorry, I said meta search catalog client. No, it was a quick map service. Sorry, I just I had too much plugins installed. Don't do like me, or do like me because it's really interesting to see all what all the community do. So it's a quick map service. And so first we will. We will so when you have quick map services, we will be able to have like a menu like this, and with this menu we can just look at having some base map. I have like the big satellites. Up, we can zoom in. So it's basically getting to have like some insights. And then we will start to drag and drop our data. So you have in these folders for the all data, and we have when you're looking at for the land cover map, you have 21 classes. In 21 classes, it doesn't look very interesting like this, but you have a property, a style property. Okay, so you with the legend provided in our file. So all this information could be found in the QML file. So you right click on land cover copy, you go on symbology, style, and the lock style. Of course, every windows for me are opening in my cover, and then you open the selected file. So you will have a land cover map style inside your files. So you can have a nice display. So here are the land cover map. So you can see all different classes here. So we went through the raster map, which is only the labels between 1 to 21. And for each value, there is a corresponding classes, which has been saved into the QML file. So that's our first layer, where we'll be working on it. And we also need to load the each risk. So yeah, the flood hazard and the landslide. So for each kind of hazard, there is a different level of risks. For landslide, it's susceptibility. One is low susceptibility, three is big susceptibility. And for flood hazards, it's the depth of I mean the height of floods in the area. So one, it's like to the ankle, two, it's the waist, and three, it's over the head or something like that. I don't remember exactly the terminology. But what we can do is change the symbology just to have a quick idea, because in a light chain like this, it doesn't provide much more insight. So, for example, for floods, we are going to the blue. So in really deep blue, it's like high risk, and light blue is low risk. And same for the landslides. But not really blue, because it's not water, or partly, we can say. We're going in red. So same. So when we just do an overlay like this, it's really artistic, isn't it? But we can have really insightful information when we just overlay everything like this. So we need to do some operations in order to excite you with the information. So the first part will be to know and to quantify the most affected classes by each hazard. So you have between three to six, the 3 to 6 parts on the workbook. So I let you follow this, and then we'll do it together using QGIS. I will do it after with QGIS. So I will let a little bit follow the instructions, and then I will come back and we'll do it together on schedule. So if you have any question, if you want anything, please ask or look on this page.
I have a question. So maybe I missed it, but can you discuss the raster values? So for example, for lenses or both of them,
So
1 to 3,
what I said, susceptibility. The susceptibility. One is no susceptibility. Three is high susceptibility. It's really driven on the flow. But there are also other indicators. I'm not an expert on this data, so there is I forgot to add the readme file where I describe their modeling because there are some modeling involved in this. And for flow data, it's quite the same. I think they use some LiDAR data in order to compute this. So using LiDAR and some flow modeling in order to see where there are the hazard levels. So for red, it's like over 1 meter and a half. So it's like in between, and one is like ankle level. Depends on the description. For the free, the number 3, I forgot to tell it's the raster calculator located here. So please don't hesitate to. So it's the little formula. It's for the raster calculator. For this. Yeah. You and you see that every witness as a class. For history of music, this one, this is going to be, let's say, Wi-Fi, so we can find it, and then actually it will already give you the number of placement is. Yeah, now it will be involved on the thing. It should be yeah, it's not very hard. When we positive, so let's say that was yeah, you can just and then when you go to well, each class, interesting and we also produce it, so that's it's just a huge exposure. And that's Additionally, it could be box of get but yeah, you can create it on your you can create it as something for development. You can take that is take that in I mean, it's for example when you run the next one, there's a problem of when you start there is a single thing to stop. So I don't know if it's common when you do these regulations coming out to share also to sure. And all this, yeah, community to do that, so. You apply to formula and you check what's more. So we, 5 years ago, was here. Selecting is where also also use the whole time. But is ready when the walk. So basically you just along the landslide. Everything is okay? If you have a question, go ahead. Yes. So the next question is valid. Okay. And how we going to block the I'm going to yes, there is a couple of to change course. Say that. Is you have like your own and have takes the same symbology as also the same problem. Because it's basically just girls. So that's what. So, okay. Yeah, go to that's what I was. I don't Well, you are still on the second. So there's like yeah, sure. Okay. I believe that is minus 2040 and because it's a no data that it's like for example here outside in the ocean we have a computer and it's no data. Yeah, it's not. Yeah. It's not like a code. So what is that? You mean, for example, okay. I will combine points. I will present maybe step by step. And then we can do that. You're welcome. It's a really good question that I think I didn't think that basically it's because all classes are not finished, but it's not the critical number, but it's not one to 24 outputs. I don't exactly know why, but know that at zero, one is force, I think I mean there is different classes corresponding, and then you can see the correspondence if you go inside the line program, for example, and you have the symbology. So you know like
I see the it's not.
no,
That's a question. I see.
no, it's not insurance functional.
Thank you.
Yeah. Um, okay. I think really working it. Okay, I will just do the small presentation of the parts 1 to 6. I mean, I will only do the part 1 to 3 because I'm lazy, and the 4 to 6 it's a repetition. So okay. I can see you and I can see the screen like this. Okay, perfect. So so you have something like this. The idea now is to create a mask with all areas affected by flood. So what do we do? So we use raster calculator. So the raster calculator is a tool that no, you don't disturb me. I go always. Okay. So the raster calculator is a tool that allows to do some operation between rasters, like you can sum up, you can divide it. I mean, any logical or mathematic equation, you can do it. On it's really not very. I will cut it sound. Not quite easy to handle. It's you can select the operator and do the operation. So here the idea is replacing on the oops, I don't know why it does that. It's replacing the the pixels where we are flooded by the land cover classes. So basically, we are using if we have some flood data equals 1, or I'm doing this way, or flood data equals 2, or flood data equals 3, which correspond to our 3 classes of floods. Then, when you do like this, you say that you replace it by the CopPhil classes. Otherwise, you say the value is 0. And then you will just writing on disk. So here we can say create a flood by class, for example. It will be raster, so type file. And then we can compute. If my computer let me do so. Okay. I don't know if there are possibility for me to. I cannot change the size of this. Okay, give us some problem. So it's computing the flood part. So you can see you have the same area of the flood, well, the flood raster, and then you can change the style by using the same style as for the land cover map. Land cover map, okay, and okay. So as you can see, you have a daily place affected by clouds, classes by land cover classes. And then what we'll do is using the unique value calculator. It's create the unique report, the raster layer unique value report. So you can find it like this, or in raster and raster analysis. So either on the menu on the top, or you can find the processing toolbox and enter the name of the algorithm. But yeah. So double click, and it's open not on the right screen. So the idea is it will generate a report, like a file saying which classes going as I mean the sum and the count of each classes and the area they represent on the map. So I do it everything on the not everything on this, but yes, such a table like this. So you can create a temporary layer and you run. So you have a unique value table here. And so you can see when you right click and click on attribute, open attribute table, you have for each class the count of pixels falling in that, inside that class and the number of square meter of that class. So as we already selected the places affected by flood, what we only need is to sort by the IS area to see which classes are affected most. So did you find for the floods where classes are which are most affected by the floods? So here, so you see here there is on the left the values from the land cover classes. How can you get the information saying which class is it and what does it represent each value? So little spoiler alert, you can find it in the symbology property where you have the value and the corresponding color of each class. So we saw that 1 is closed forest, 4 is open forest, and so on. So here we see that the most affected classes for floods, it's the annual crop classes. So you see that there is a high risk of damage and of floods on crops, which kind of makes sense, I would say, because crops are really often installed in floodplains. So this is for floods, but is anyone here finishes it for landslides? We did it for landslide. I saw some already passing to another exercise. So I know that some have finished both floods and landslides. So for landslides, does anyone can give you me the most affected classes by the landslide hazard? Sorry? Yeah, it's closed forest. Closed and open forest are the two most classes affected by landslide, which kind of makes sense because where we have the highest landslide risk is the places with the most slope. So basically, if you build up on these places, except in this area where we have a city, I don't remember its name, but there is around it quite an important risk of landslide just nearby. But otherwise, it's really often not really use terrains where there are very high susceptibility for landslides. So, okay, now that we just look at the which classes are most affected, now we are trying to see which city is most affected in this area by the floods. We only stay on floods because it's the one that affects the most built-up surfaces. So for policymakers, it's probably the most important to look at. So we will continue and from the 7 to 2 p.m. So same using raster calculation, you create a mask with built-up areas and so on. So I will let you do this and do the same as earlier. And then if you have some question, please don't hesitate. Yeah. I mean, I didn't understand. And when was so what was the okay. Go back to the master area. Yeah. 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 Okay. And so all you so don't say this in this video. I think it's weird because when I don't say this as a single report, but you can say this. I don't think we should just like out that's what because you choose HTML5, but you can choose like so I think you can read save it as a GP KG. So je pas KG now the same is not yeah, but same as the pages. Yeah. Like this, and maybe because in my case the results and you know our payments they go back to the so please go and why comment and why data and yeah it doesn't like yeah and that's I do not your notes yeah what do you get first time that's yours it's on so I think I okay, no, because so yeah, 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 and just yeah. It's like I don't know what how maybe when the husband was choice from close to the meetings where we was. Okay. And then here you have like you like this. So first you have like the field where you have the ID of classes. It's a so I don't I think yeah, thank you. That's and that's it. That's what So it was really bad and actually change it from by step. Okay, everyone, I made a small mistake in when you arrived in the point 11, the set function is not count, it's sum. So 11 is not set function equals count, but sum. Sorry about that. There you go. All right. So actually, it's part of the report saying that so basically all these cells doing the so this also do all here so you can give it by selecting only what you or whatever yeah if I see that it works those things that yeah so so Right. And then say,
That's why I'm going to say that
I don't think like it. Yeah. So it's really set the beat of the response, and then you wait to learn and explore. So I like the main yeah, and here you are like
so.
every so just so it's easy. And
It's important here. Online. And that's it. And it's
that or
agents.
yeah. So
I don't know.
when they are so here you are doing from this order. So to on the real values of the one. So it should that be so even when this point, even when so the division is quite important. Like in sort of codes. And then you just want government space here and here you set the want to use the search of every not so this one, of every space, of every entities. So we created a string class with and then for so the name is so it's probably then this one of the but for the so that you know and the zero calls then you can that's what it's need for charity fantastic well objects objects and very cool. And now we can yeah, I mean, nothing for this. So I will mention in screen, but okay, in 2 to 3 minutes, we will do the correction and then that's everything. See if you find the right thing. I also I should have some option for which one?
Yes, and here.
It's like,
Yeah.
yeah, it's like a button function in French. Like, yeah, yeah. Yes. Sometimes in
You always came here. Yeah, February, and we have like a small.
that's up right now.
Yeah, yeah. It's going down. Yes.
Yeah, so, uh, uh,
Or is it given? Extremely more. All the years that are in this. That's why. I mean, it's. I think it's completely more. Yes, yes, exactly. So it's all like. And the everything was. Problems like that. Lines another marriage. But I'm not to go to them on. And I was. But it's a lot of data. Don't have to go into there connected. It's here then. Here.
even for those, it's not nice to have to work with police. When it's like so. So, when we are going to come up or,
I don't think it's going to talk to you.
or,
And
yeah, I will start with the presentation for the, I mean, the question for this, but, so, yeah, so we wanted to see the built-up areas affected for each city. So the first thing to do is to create using a raster calculator. Is to create a raster file containing the all the flood hazards for built-up areas. So we do kind of the same thing as last time, but now I don't know why I cannot. I don't know why I cannot see the bottom of my screen. Yeah. Or I'm minimize the operator
show that part for the population.
Yeah. Oh, this one.
If that done,
Yeah. Yeah. I think I don't have the calculate thing, and there is no. So you have to mark my words, but I will do it on my screen. If that's that's nonsense. Okay. Anyway, I think that everything is going to record. Okay, so we enter the expression here. So we basically for the each built-up area for built-up areas for each risk, we selected each risk and exported to a new layer. I don't know why it's doing like such Okay, better now. Okay, so we can save it to file. So for example, I will name it flood risk build-up. The file, okay. So it does the calculation, and then we have all areas. So where there are the greater risk, meaning that we have some built-up places on the area. So increase the places with greater risk. So we have some built-up areas here and some area with less risk because it's not built up. For example, it could be crops or forests. So area of less interest, meaning that there is less damage and socioeconomic damage. From this part, we will transform it into a shapefile, vector, basically. Not a shapefile, because so to a vector file, in order to intersect it with other kinds of data. So what we can do is using raster conversion recognize with the input layer. We'll have the name here to create. It will be the DN. As I'm lazy, I will keep it as the temporary file. It's better to save it as on disk when you're working because less risk of losing everything and less memory temporary file involved. It's better. So now it's polygonizing. So you have the same risk map as before, but in vector format. And using this data, we're going to intersect with some with the administrative layer. So we have like the, and I see that I didn't. So first things to do is to load the the administration layer. Yeah, so we have now the administration layer. As a overlay layer, it's vectorized. And we can create as well a temporary layer with the intersection. And we can run everything. So meaning that we are going to cut our administrative layer with the polygon of risk we had previously. So polygons everyone. Yeah. So as you can see here, you have the city administrative borders, and you have also the floods. Yeah, yeah.
For the infrastructure, the answer that to your state that the land overflow should be painted. The which is the built up area. And, however, for the output, I think it's getting layers that are areas that are not good. So if
You mean, I mean, okay, I see what you're asking. You're asking for this part. Yeah, I mean, we extracted all floods area, and we put on a layer of risk when they are built up. So, for example, here in deep blue with free, it's a built up area. Sorry. Okay. it's the intersection of built-up and the risk the risk area, meaning that we have our floods here, and we have the built-up detected here. So when we have we just put at 0, so in white, what is not built up, and we left the level of risk, for example, 1, 2, 3, when they are built up. I'm clear, or maybe not. Yeah. I think that we just have the flood layer, and then we just, so with classes 1 to 3, and then every classes that fall outside the built up areas are classified as 0. But we left the level 1 to 3 to have the different level of flood hazards. I'm not clear. I see in your eyes. So I can see it. Meaning that when with the questions maybe a little bit more clear. So, not yes. So yeah, when we did lots of calculator, we did this, meaning that for the CopPhil layer 20, and the CopPhil, so 20 is like the computer, when they are built up and the classes of higher the flood risk equal the flood hazard is equal to 3, we said that there is a high risk, we said that there is 3. Same for the when there is flood hazard equals 2, the same for hazard equals 1. So we're keeping basically the flood layer value when they are built up. But when they are not built up, it's classified as 0. But the thing that can probably misguided you, it's that the representation is classified as 0 and not data. But basically, what we can do is just starting from okay, so we want the 0 being no data. So we have something like this. Is it maybe because the symbology was misguided? Now do you understand a little bit more? It's because we represented all flooded area with the 0, but it's kind of, it was kind of the wrong representation. Here we can see now only the built-up areas that has been affected by floods. So it was just a story of representation. So only what we did is take the built-up areas that are in the flood affected the hazard flood layer, and then represented each different classes of level of hazard. So meaning deep roots, high level, and white is low level.
Exactly, because in our process, there's still in your layer, there's 1, 2, 3.
Yeah.
But in our product, there's 0, 2, 3.
Yeah, 0 is like no flood.
And then, however, because it's in our process, the 0 is still there during the intersection.
Yeah.
Later, still included.
Yeah, because we can define it and say, yeah, it's not existing. So the zero must be, at one point we can say, okay, I don't want to have this value involved. But yeah, it should be, it's because the raster calculator is not entirely correct. I should have not created as zero, but that, because the no data value, and someone asked me earlier about the no data value, but when you look at it, and for example, power map is the same, you know that the no data value is minus 3, blah, blah, blah. Yeah, so, yeah. So, okay, let's continue this. When we have in the intersected shapefile, we need to, so we have all places affected, the orbital areas affected by floods. And then what we need to do is to create a new field with a surface area. So we toggle addition, do a field calculator, and we have this window opening. So we create a new thing like surface flood. We'll do a decimal number because yeah, we want like we can change the precision if we want, and we select area and we do OK. And so now for each object, you have now surface flood information, surface information. So we set it. And the last part is using the group stat module here, which is not opening. I don't know why. Okay, sorry, it was opening. Sometimes saving your files is quite important to manage the memory right of your computer. Because I don't know why it doesn't want to open the group stats. Yeah. I don't know why it seems to be in another window. I'm sorry, I have a quite I don't know why it doesn't want to open. Oops. I think it's one problem of display. I will just change the layout just quickly. But for the end, we have the GroupStat plugin. I will not show you this because I don't know why it doesn't want to display. But basically, GroupStat it's a tool that allows you to have a nice representation and to do some basic math on vectors. So basically, what you did, you select what you want to present on the table, selecting the arrows and the column information, the rows and the column information, and then do the calculation on both of these fields. So you should have for each row some cities, so the name of the administrative entities. So it's the field admin and full for the malaria administrative layer. For the column, it's the value of blood. So in my case, it was DN, but it depends if you give it the name or not. And on the per box, which is the result, it's the function, the sum of every surface areas to have the surface for each flood and each city. So now, what is the municipality least affected by floods, particularly hazards, with the higher flow hazard in this case? Did you find it? Sorry? It's Orion? Are you sure? For the highest level, for the level 3.
It's not even
With 1.45 square kilometers of affected by floods of intensity 3. Yeah, well done. So if you have some question and over discussion you want to open, please return the file, the workbook file with your question or issue. So we have some we can answer it later. So that's it for the exercise. Now we can go on the last part of the presentation, which is more about our UK use case that you can add using the land power product. You can. So some ideas and other use cases that can be useful to have some more ideas on how to use land cover, and maybe can give you some ideas. Maybe it will more rings than natural hazards because it's really more close of your use case. One example I showed you here, it's an example from CESA, which is a Center for Studies and Urban Planning in France, where they basically, once we encounter with climate change more and more heat waves, so the idea here is to present for decision maker a tool and a map where they can show the heat island, where meaning that it's a place where the heat descends slower at night. And the idea was to do so by using different sources. It was land cover, DMs, and some other products such as the Ember business companies products in order to produce this map and help decision makers to better manage heat waves and to see where they need to put some greening efforts in the future. So here in the city of Toulouse, where I come from, so you see that the city center is very well organized. There is very few green, but when we look at on the outskirts, there are less vegetation, so the area is less sensitive to the heat waves. Another use case that could be interesting. So here it's an example from literature. It's a case for urban sprawl. So when I said land government itself is an interesting information, but which is also interesting, it's comparing different land governments. So here it's an example between 2020 and 2024, where the authors were looking at the development of the US city network. It can give a little bit some insight on some trends for some classes, for example, the increase of urban and some forest area, but the decrease of agricultural land and unused land in the student areas. And so geospatial analysis here was on media to understand all the urban sprawl was evolving, and for example, looking at the direction, the shape, the connectivity, and so they identify some causality between urban sprawl and some policies that have been made in the past decades. For example, before 2010, the urban sprawl was not completely directed, meaning that it's really depends on the topographic condition of the area. But after this period, between 2010 and 2020, it was more driven by the economic development of the area, meaning that residential and area are developing around the industrial park, for example. So it changes direction in time. Yet again, another example for the for land cover use, it's here for the EEA, the idea was to derive some statistics over all Europe using the colonial cover maps between 2012 and 2018, and to see to have some insights and some trends all over Europe, depending on the classes. So you see that between 2012 and 2018, the changes in land cover classes. So basically, a big increase of urban and an increase of over national classes. You can see statistics for every country in Europe. So you can learn like the next urban policies and next ecosystem and biodiversity preservation policies in Europe. And last example of habitat conservation is another example from the literature. So the author here were studying between 1995 and 2015 some land cover maps to look at the biodiversity around national park in India. And so the idea was to look at the changes for each classes between these different times. And what they saw it was present mainly a decrease of forests, an increase of plantation, open forest, divided vegetation classes, and also an increase of augmentation of the forests in the area. And so they could see that, but it was also to have data, for example, the increase of casualties and non-casualties by trade or war, for example, with big mammals like elephants or leopard and so it was really important for them to do a prediction of what we're going to do if the trends continue in 2035. And the idea was to go on into a locate area where to put preservation efforts. So it was like some small ideas of what to do with land cover areas, but be aware that everything is driven by the quality of data and the data sets you have as an input of all these studies. So that will be my final goal. And I thank you very much, Samantha. And it was really a nice pleasure to be with you today. So, thank you.